the second assignment. So these are the questions that I have in my second assignment. So I have around 9 to 10 questions even in second assignment. So as you see, we have 10 questions here also. So let's see the first question. Again, for all these questions, we are going to use this dataset cells and other datasets that we are going to use are part of programming 2 folder. So we'll issue a new libname command to connect to programming 2 folder. So let's destroy or delete our current reference that we have with programming 1 and then create a new reference. So I say libname imart, then I say sequolin SAS foundation prj2 before this, let me destroy the previous reference. I just say libname imart clear. So it's destroyed as you see. Now let's execute this libname command, which is going to create imart once again and referring to a new library. So now we have this imart created again, and if you see, now we have different datasets in this library which are fetched from prg2 folder of SAS foundation. Now if you see, in this particular case we have used the entire path. You can change this default path and set this as your default location. In that case, you can avoid every time when you are accessing a file from this particular path or when you are creating a library reference. So you simply double click this drive letter and browse to that path that you want to set as your default path. So go to C drive, SAS foundation, prg2 folder and say OK. Advantage of this is, if I destroy my library reference once again and show you how to create it. So I remove that imart library reference once again, and now let me specify this libname command in a different manner. So I say libname imart, and now I'm not going to specify the path. I'll just say empty quotes. When you say empty quotes, SAS will by default refer to the location which is set as your default path. So just say libname imart and then followed by this empty inverted quotes. No need to specify this complete path. So as you see, that reference is created once again, and if you open, you will see the same set of data sets created again. Okay, now let's provide the solution for all the assignment questions. So the first question was, create a new data set with following specifications. It should have only 5 variables, namely employee ID, first name, country, gender and salary. This was the first requirement. So remember these variable names. First name, so you need employee ID, first name, country, gender and salary. So let me write the code for this. So we'll say data, the name of the data set, I say new DS, data new DS, then I say set. We have to use the input data set cells. So we say set emart dot cells, and then we say keep employee ID, first name, last name, employee ID, first name, last name, gender, country and salary. So hope these were the variables: employee ID, first name, country, gender and salary. Last name is not needed. Country, gender and salary. So let's remove last name. So employee ID, first name, gender, country and salary. So this is what you need to write. So this will create a data set with only these variables written to your output data set. Let's go step by step. Let's first execute this piece of code and see how our output data set is created, and then we'll implement the other requirements. So as you see, now after compilation, it's creating 165 observations and 5 variables in my output data set. So it is reading 165 and 9 variables from input data set cells, and in output data set it is writing 165 observations and 5 variables. If you proc print that output data set, I say proc print data is equal to emart dot new DS. If you see new DS we have created without using the library reference. So this must have got created in work library, for which you need not write any library reference. You just say proc print data is equal to the name of the data set, because by default if you just specify the name of the data set, SAS reads the data set from the work library. Now I say run and try executing this proc print. So this is what has been written to my output data set: 165 observations and only those 5 variables which were listed in the requirement. So this was the first part of question 1. In second part, we have been asked to write only those observations that are of sales representatives, which are representing sales representatives. So we need to specify a subsetting criteria on observations. In this, the way you have specified a subsetting criteria on variables using keep, so we have this keep and drop option by which we can specify the subsetting criteria in SAS. When you want to write a subsetting criteria on observations, we have this where statement, and we can write where we can say where job title contains REP. We can write, we had a similar requirement in our previous assignment if you remember. Okay, so There we were temporarily subsetting the data set. Here we are permanently subsetting the data set which we are creating at the end of the data step. So where job title contains REP, this is what you need to write. Now since we are writing job title, to see whether SAS has correctly written my job title or not, we need to print job title as well. Not necessary that since you are writing a criteria on job title, you have to have job title in your KIP list. But just to cross verify my output, I would like to see job title also in my output data set. Now if you see, the number of variables in KIP list are increasing. So it's a good idea to go for drop, where you can reduce the number of variables. I mean, you need to specify, since you are keeping 6 variables out of 9, in drop you need to specify only 3 variable names. So that code would be more efficient than writing keep and then mentioning 6 variables. So I say salary, since I have keep, let me add the job title also. But if you are implementing a smart code, rather than writing 6 variables in keep, a better option would be write drop and mention those 3 variables that you don't want to see in your output data set. Execute this. So as you see, it is writing 159 observations and 6 variables to my output data set. If I proc print, this is what it has written, 159 observations. So all those people who are having REP in their job title, like sales representative 1, sales representative 2, sales representative 3, 4, etc. So those are the observations written to my output data set. Now let's see the third requirement. First name should have a label first and first space name, and country a label employee space country. So I just go back to my code and say label first underscore name is equal to first space name, first underscore name is equal to first space name, and country is equal to employee country. Country is equal to employee country. So I'll execute this code. So my data set is created with labels. Before I print those labels, let me quickly check if those labels are, since I have added this label in my data step, I'm expecting this label to be added as permanent label. So I'll quickly check here. I say proc print. To check the descriptor of the data set, we need to say proc contents. So I say proc contents data is equal to imart dot cells. Then I say run. Sorry, we need to specify the name of the output dataset that we have created. So proc contents data is equal to new DS. Imart.cells was the input dataset. This was our output dataset. We say new DS, and we'll also specify this keyword to sequencer variables. So as you see here, my variable first underscore name now has a label which is first space name. Similarly, country now has a label which is employee space country. Okay, so here I have first name and here I have employee space country. So these two labels are added like permanent labels to my dataset. Now let me write proc print and see how those labels appear. So I need to say proc print data is equal to new ds and then the keyword label, as we saw in previous assignment, without writing label, SAS will show you the original variable names. It will not show you the labels. So to print labels in your output, you need to write this keyword label. So now if you see the variable headers, so my first underscore name variable is displayed now as first space name and my country variable is displayed as employee space country. So first space name and employee space country. This is how you add labels to your new dataset. Okay, this was this C sub option. Now the next is salary should have a format, comma, and birth date should be displayed as 2010-90. So if you see this 2010-90, this cannot be the month value. So this is definitely date, month, year. But if you see year is just 2 digit. So this is DDMMYY 8 dot. So birth date they want in DDMMYY 8 dot format and salary should have a comma in it. So let's enhance and add few more statements in our data step. And I say now format salary comma 7 dot and then I say birth date DDMMYY 8 dot. I clear my output window, clear the log window, execute this data step. And let's write the proc print. We can, before we issue the proc print, we can cross check whether those formats have been added as permanent formats in my descriptor or not. So now if you see your employee ID already had a format 12 dot. This is what I added. For salary I specified a format which was comma 7 dot, and if you just see this for birth date, since we are not writing birth date here, that format is not displayed. So now you can include birth date also in your keep list, but now if you see in keep list there are 7 variables. So I'll comment this keep now and instead write a drop statement where I just want to avoid 2 of the 9 variables. So I'll just say drop last name. So except last name and hire date, we need everything. So I say drop last name underscore hire date. Except these 2 variables, all remaining 7 variables will be written to your output data set. So execute this once again. I execute this proc print tense. Now if you see, this format ddmmyy8 dot is written for birth date variable. So now birth date has this particular format. And now if you proc print your data set, you'll see birth date displayed in this ddmmyy8 dot format, and salary having comma in the salary number. So as you see, all my salary values have a comma in them, whereas this birth date is displayed as ddmmyy8 dot. So this is how you apply format to your variable to make the values more readable and interpretable. So we have implemented all the requirements which were mentioned in question 1. So we created the data set with all the specifications. We ensured that the data set had only some selected variables. Then we ensured that I'm writing only that data where the job title of the employee contains a representative in their title. And then I created this label first space name for first underscore name, and employee space country for country variable. And then my last requirement in first question was salary should have a format comma. We applied a format comma and we ensured that birth rate was also format and displayed as ddmmyy8 dot. Now let's see the second question. So second question is, create a new library reference by reading cells.xls and import all the worksheets of that particular file. Let's see how to implement this. Before we start writing the code, we'll go to that path and ensure that we have that cells.xls file. So we go to SAS Foundation, PRG2 folder, and we'll search for the file cells.csv. Cells.xls, sorry, it was XLS file, not CSV. Cells.xls. We'll go to the previous folder, that is PRG1. So in PRG1 we have this folder cells.xls. Let's use this folder for our task. So let me implement the code for the second question, which said you have to establish a connection with that Excel file and fetch all the worksheets of that Excel file as SAS datasets. I say libname, say imart xls. Let's say this is a reference name, imart xls, and then I specify the name of the Excel file. You need not specify the complete path because you have set, let me change this and go to PRG1. We have set this C colon SAS Foundation PRG1 as our default path. So we need not write this entire path. You just say libname, library reference name, and then you say cells.xls and execute this. Now if you go to Explorer, and check this library reference whether it is created or not. Here I see the library reference Imart XLS. If I open this, you see four datasets created. Two are having dollar sign in their name and two are without dollar. The ones which are without dollar are the datasets which are representing Excel ranges, Excel's defined name ranges, whereas the ones which are with dollar sign are representing the dataset which is stored in your worksheet. So these are representing worksheets and these are representing range based data. Okay, this was the second question. Create a new library reference by reading sales.xls and import all the worksheets of that particular file. Our next requirement is create a new dataset using the library reference created above and write only Australia mail data. So we have to use this Australia dataset and ensure that our new dataset contains only information on male genders. So let's implement that code quickly. So I say data male ds and then I say set imart xls dot Australia dollar. Imart xls dot Australia dollar. As you know, this dataset name has a dollar sign. As part of its name, you'll not be able to use it in its normal or default naming convention. You'll have to write it in quotes followed by this literal character n. Okay, because this is not a valid name. This is invalid name because of this dollar sign, and somehow you need to ignore reading dollar while reading this data set. And this is how we do it. You specify the entire name in quotes followed by this literal character n, which is going to suppress the meaning of any special character used in the object name. So Australia is my object and the name is Australia dollar. So while reading this, it is going to read it as only Australia. And then you say where gender is equal to M to ensure that only male data is written to the output DS. The output data set. I execute this. So if you see, it's writing only 36 observations. It seems we had 68 people from Australia. Not 68, 63 people from Australia. We had 63 people from Australia. Out of 63, there are 36 males and remaining are the females. So we have around 27 females and 36 males in Australia. So if you proc print, you will see only these 36 observations written to the output data set. So I say proc print data is equal to, you need to say male DS. There's a mistake in the dataset name. So this is how the male data has been written to the output dataset. So if you see, this output data set has information on Australian males. So only 36 observations, because it seems out of 165 there are only 36 Australian males. So hope this was clear to you. Now let's see the next business requirement. Let's see what is the next task. Question number 3. Hope we met this requirement. We created a library reference, and then we created this output data set where we ensured that only male data from Australia is written to my output data set. Okay, question number 4 is create a new data set using cells.csv and write only employee ID, first name, salary and country variables. Ensure only those names are written which starts with letter S. So we need to create a new data set using cells.csv and write only employee ID, first name, salary and country to it. And we have to ensure that only those names are written which starts with letter S. Let's write this code, and the input file that we are going to use for this is cells.csv. So we'll go to our path, and check for this dataset cells.csv. This is the one. So this is what we need to read, and then after we have to ensure that only those names are written which are starting with S. So I clear my output window, I clear my log window and write that code here. So I say data test data set. So I say test ds, in file cells.csv, dlm is equal to comma, then I say input. Based on the sequence of the data, so I go to C colon SAS Foundation PRG1 folder, open that file, so this is employee ID, this is first name, this is last name, gender, salary, designation or job title, this is country, this is birth date, and this is hire date. So let's say this was a suggestion given by my business users that you need to consider this as employee ID, this as first name, last name, gender, salary, etc. Now as per their requirement and business specification, let's write a code, a SAS code that will read this raw file and write these values to appropriate variables. So we'll close this, go back to SAS editor and write the code here. So I say input employee ID, Then I say first name or say F name. I'll make this a little shorter. I just say EMPID. First name I want to read as character. L name I want to read as character. So first name, employee ID, first name, last name. Then we had what? We'll just go back to that file once again. So it is first name, employee ID, first name, last name, gender, salary, designation. First name, last name, gender, salary, designation, gender, salary, designation, country, birth date, and hire date. So input EMPID, first name dollar, L name dollar, gender dollar, salary, designation dollar, country dollar, birth date and hire date. Now I say run. Semicolon here and then run. So the dataset is created. Let's proc print and see. So I say proc print data is equal to proc print data is equal to test DS and run. So as you see, it's reading everything for me except birth date and last date. Birth date and the hire date. If you remember our discussion during raw file handling, we discussed and classified numeric values in two categories. We called some numeric values as standard values and some numeric values as non-standard values. And we concluded that SAS can easily read all those values which are standard. For example, if you have a value 1000, or if you have a value 0.25, or if you have a value which is say 10E4, which is scientific notation. For SAS, all these values are standard numeric values, and it doesn't need your help or instruction to read these values. But when SAS encounters non-standard values are those which, those numbers which have a comma in them, or which have a currency sign, or which are normal date formats like date 9 or DDMMYY or MMDDYY or week date, word date. It seems SAS cannot interpret or understand these values easily. So you'll have to help SAS by specifying something called as in format. So after identifying the correct format of that particular value, you'll have to specify it as in format. So you need to say birth date colon date dot, and then you'll have to say hire date so let me see in what format hire date was. I guess that was MMDDYY. This is date 9 and this is mmddyy 10 dot. So I say higher date space mmddyy 10 dot. So if I execute this code once again, now you'll see some values written to birth date and hire date. So let me write a proc print. So now if you see, birth date and hire dates are written to my output data set. Now to decode that birth date and hire date, or to format birth date and hire date, you can also again add a statement, say format, and then you say birth date. You can restore its original format also. You can say format birth date, date 9 dot, and hire date, you can say mmddyy 10 dot. So if I clear my output window and log window and execute this once again, so as you see now, it has restored back the original format of my raw file, where the date was in date 9 format, birth date was in date 9 format, and hire date was in mmddyy 10 dot format. Now if you see, the only problem that I feel is the job title values or the designation values are not shown completely because of the short length. By default, when you create your variables in input statement, all those variables are assigned a length of 8 bytes. Now that length of 8 bytes is not sufficient to hold those values which are more than 8 characters, because in character case 1 byte is 1 character. So in case if you have some character value which is more than 8 bytes, you will have to declare that particular variable's length explicitly using length statement. So here you need to say length designation and then you say $15 dot. In this case, designation will be shown before any other variable, because this is created before any other variable. Other variables are getting created in input, but length is getting created before input. So now if I execute this, and proc print this, so if you see, all my job titles are shown correctly now. So earlier I was getting only 8 characters, but now I see all characters of my job title. As you see here. So this is how you read standard and non-standard data from your raw file. Let's see the next requirement. Okay, before that, we need to perform a subsetting criteria and ensure that only those names are written which are ending with, which starts with letter S. So let me put that criteria. In proc print, I just need to say simply where I say where first name, F name like S%. Meaning of this is, show me all those names that starts with capital S followed by any number of characters or any characters. So if you see all these first names, so it's fetching only 18 observations. It seems there are only 18 people out of 165 employees whose names begin with S. So if you see all these names are beginning with, just observe the first name column. All these names are beginning with letter S. So please remember the syntax of this. When you are deriving or when you are fetching the patterns from your data, you can use this like operator, which is a pattern matching operator, and you can fetch such type of outputs. You cannot specify this in your data step, because when you are specifying where, it works only on defined variables. It's defined when you are using it in proc print, but it is about to get defined when you are working in the data step. So here if I write where, this will give you an error saying that variable f name does not exist. So remember one thing, this where operator works only with input data sets. In case if you want to perform some subsetting operation on raw file data, you'll have to write that using if condition. You'll have to use the subsetting if statement, because that's a PDB level option. So in this case, if I say where and write f name like S%, where f name like S%, this is going to give you an error saying that f name not found, because it will start searching this data set. It will start searching this variable in a data set, and there is no data set in this particular case. So this is going to give me an error. So it's writing 0 observations in the output window, and it's saying no input data set available for where statement. So please remember, in case if you have to perform some subsetting criteria on variables created by reading raw file, you'll have to make use of subsetting if and not this where operator, because this where statement, because where statement works only on defined variables. It doesn't work with computed variables and raw file variables. And these operators works only with where subsetting option. Most of the operators does not work with this if subsetting criteria that we have. So as you see, this is writing 0 observations and 9 variables. SAS is unable to interpret the meaning of writing this if f name like S%, because most of these operators can be used only within where statement. Because if you change it to if, then probably you will not be able to read those. SAS will not be able to interpret those operators correctly. So you'll have to write where, that too in proc print and not in this data step, because it's too early to subset the data in data step. So once it is created, and all my variables are written to some output data set, you can apply this where statement and fetch only that data where the name is beginning with s percentage, that is beginning with s and followed by any number of characters. So percentage here is representing any number of characters or group of characters after this first character capital S. So this was the solution for question number 4 that we had in our question set. Now let's see question number 5, where we are asked to create a new data set using the same existing sales data set and write only following variables. We need to write employee ID, first name, salary, employee ID, first name and salary, only 3 variables to this new data set. Your new data set should contain data of only Australia. That's the next task. So write only following variables in your new data set: employee ID, first name and salary, and your new data set should contain data of only Australia. This looks simple. So you just need to say data step. I mean, you say data, let's say test data set, and then I say set imart dot cells, and then I say keep employee ID. What was that? Employee ID, first name and salary, I guess. Yes, first name and salary, and then I say run. Also I say where country is equal to EU. I hope this is what they were looking for. So they said that you write only employee ID, first name and salary. Employee ID, first name and salary, and the new data set should contain data of only Australia country. So this is how we achieved it. Now if you execute this code, if I proc print this data set, so proc print data is equal to mart dot test ds and say run. This is what has been written to. You need to suggest test ds. This is how you are going to get your data, where the first variable is representing employee ID, second is representing first name, and third is representing salary. So this is the solution of question number 5.